Please subscribe and tap the bell icon.
Second bit, first question. Find the domains of the following real valued functions. First one is f of x equals to square root of x square minus 3x plus 2. For this we need to find the domain. For this function to exist, x square minus 3x plus 2 should be greater than or equals to 0. It should be always positive or equals to 0. Factorizing this, I'll get x minus 2 into x minus 1 more than or equals to 0. So x should be more than 2, x should be more than or equals to 2, or x should be less than or equals to 1. If I draw the number line, this is 1, this is 2, and x should be more than 2 and x is less than 1. So this is the domain. Domain equals to minus infinity to 1 union 2 to infinity. Second question, f of x equals to log of x square minus 4x plus 3. This is defined only if x square minus 4x plus 3 is more than 0. Even if it is 1, it's okay, because log of 1 is 0. But log of this function should be always positive. On factorizing this, I'll get x minus 3 into x minus 1 as more than 0. So x should be less than 1 or x should be more than 3. This is 1, this is 3. So x should be 3 to infinity and x should be 1 to infinity. So domain equals to minus infinity to 1, and this is the open brackets union 3 to infinity. If x equals to exactly 1, then this total thing will be 0. So log 0 is not defined. So minus infinity to 1 union 3 to infinity is the domain. Third one is f of x equals to root of 2 plus x plus root of 2 minus x by x. So first condition is that x should not be equals to 0. This is the first condition. And also I have the square root here. This 2 plus x should be more than or equals to 0. But since x should not be equals to 0, this condition is not here. So this can be taken out. 2 plus x more than 0. So x is more than minus 2. And also 2 minus x is more than 0. X minus 2 less than 0. X should be less than 2. So I can say that this is minus 2, this is 2. X should be more than minus 2. So it falls in this direction. And x less than 2 is this direction. So this is my domain. But here we need to take out this 0. Domain equals to minus 2 to 2 minus, take out the value 0. So this is the domain. Now if this part is 0 here, this can be valid. So domain will be equals to minus 2 comma 2. So we need to put the square brackets minus 0. If x equals to 2, there is no problem. If x equals to exactly 2, then this will be equals to 0. And if x equals to minus 2, this will be equals to 0. But my total function is not getting affected. So instead of the closed brackets, I can even write the open brackets. So overall the domain will be minus 2 comma 2 to minus 0. So this here 2 plus x can be assumed as more than or equals to 0. Next is fourth one. F of x equals to 1 by cubed root of x minus 2 into log of 10 to the base 4 minus x. This can be written as 1 by x minus 2 whole power 1 by 3. Log 10 to the base 4 minus x can be written as log 10 to some base e by log 4 minus x to the base e. This is equals to 1 by x minus 2 whole power 1 by 3 into log 10. This log of 4 minus x comes to numerator, so it's log 4 minus x to the base e. This is defined only if 4 minus x is more than 0. X minus 4 should be less than 0 and x should be less than 4. X should be less than 4. And also in the denominator, this x minus 2 should not be equals to 0. So x does not equals to 2. Now for x less than 4, I'll get the values as 4, this is 0, minus 1, so on. So this is the domain, and from this we need to subtract 2. So 2 should be eliminated from this. So the domain will be minus infinity to 4 minus, we need to subtract 2 from this. So this is the domain. Minus infinity to 4 minus the value 2. Next is fifth one. F of x equals to square root of 4 minus x square by step x plus 2. For this function to be defined, this total part should be always positive. 4 minus x square by step x plus 2 should be always positive or equals to 0. This is true when we have two cases. The first case is that the 4 minus x square is more than or equals to 0 and step x plus 2 should be more than 0. Step x plus 2 should not be equals to 0, because if it is 0 then it will be undefined. And similarly, second case is 4 minus x square can be less than or equals to 0 and my denominator step x plus 2 will also be less than 0. If we solve these two conditions, we will get the domain now. For this, x square minus 4 is less than or equals to 0, so x minus 4 into x plus 4 is less than or equals to 0. So minus 4 less than or equals to x less than or equals to 4, and step x plus 2 is more than 0. Step x should be more than minus 2. Step x is more than minus 2 for all the values of minus 2 to infinity. From minus 2 to infinity, I'll be getting the values more than minus 2. So if I plot on the number line, this is 0, minus 2, minus 4, plus 4. So first case is that x should be lying between minus 4 to 4 and step x is more than minus 2. So this is the condition. But for step x more than minus 2, if step x equals to minus 2, denominator will be equals to 0. This step x plus 2 should not be equals to 0. Nothing but step x should not be equals to minus 2. Step x is minus 2 in the interval minus 2 to minus 1. In the interval minus 2 to minus 1, step x is always equals to minus 2. So if step x equals to minus 2, the function is not defined. So from minus 1 to 1, from minus 1 to minus 1, this part here should be eliminated. The first condition is that minus 4 to 4 minus, we need to subtract minus 2 to minus 1. And solving the second condition, this is 4 minus x square less than or equals to 0. X square minus 4 is more than or equals to 0. This is x minus 4 into x plus 4 more than or equals to 0. So x will be minus infinity to minus 4 union 4 to infinity. So this is the first condition. And the next condition is that step x less than minus 2. Step x is less than minus 2 for all minus infinity to minus 2. So plotting everything now. The first is minus 4, 4. Minus infinity to minus 2 is, so minus 2 to minus infinity is the first one, and 4 to infinity. And the second one is minus infinity to minus 2. So again it is this one. And this condition is minus 4 to plus 4. So minus 4 to plus 4 is this. And subtracting this minus 2 to minus 1. So this part here is this. So this part here is, it's not there. It is not there. I'm combining everything. So domain will be equals to minus infinity to minus 4 minus infinity to minus 2 union minus 1 comma 2. So this is a required domain. Next is sixth question. F of x equals to square root of log of x minus x squared to the base 0.3. So x minus x squared should be more than 0. X into 1 minus x more than 0, and x into x minus 1 should be less than 0. X is lying between 0 and 1. So domain equals to 0 to 1. Seventh question is f of x equals to 1 by x plus mod x. So for this, the domain should be always positive. If I put x equals to minus 2, let's say, then x plus mod x will be equals to 2 minus 2, which is equals to 0. But this part should not be equals to 0. So for all the positive values, it is defined. So it is 0 to infinity. If it's exactly 0, then it will be 0. So it's not defined. From 0 to infinity, for all the positive values of x, it is defined. Next is second bit. For all the real values of the x, f of x equals to x by e power x minus 1 plus x by 2 plus 1. We need to prove that this function is even function in the interval r minus 0. If x equals to 0, then this will be 1. 1 minus 1 is 0, which will be not defined. So this function we need to prove its even function. Nothing but f of minus x should be equals to f of x. This function equals to, on taking the LCM, I'll get 2 into e power x minus 1 is the LCM, and this is x into 2 into e power x minus 1 plus x into this is 2x plus x into e power x minus 1 by 2 into e power x minus 1 plus 1, that equals to 2x plus x into e power x minus x plus 2 into e power x minus 2 by 2 into e power x minus 1, that equals to 2x minus x is x minus 2 plus x into e power x plus 2 into e power x by 2 into e power x minus 1. F of minus x will be equals to minus x minus 2 minus x into e power minus x plus 2 into e power minus x by 2 into e power minus x minus 1. This is equals to minus x minus 2 minus x by e power x plus 2 by e power x whole divided by 2 into 1 by e power x minus 1. This is equals to minus x into e power x minus 2 into e power x minus x plus 2 by e power x whole divided by 2 into 1 minus e power x by e power x. These two gets cancelled, that equals to minus x into e power x minus 2 into e power x minus x plus 2 by 2 into 1 minus e power x. On taking out minus common, x into e power x plus 2 into e power x plus x minus 2 by 2 into e power x minus 1. So this is x minus 2 plus x minus 2 plus x into e power x plus 2 into e power x, nothing but f of x. So f of minus x equals to f of x. So f of x is even function. Third bit, first one is f of x equals to tan pi into step x by 1 plus sine pi into step x plus step x square. So this is the given function. We need to find the domain and range of the following functions. So domain equals to, x can be anything here. So for whatever the value of x, the function is defined. So domain is real number set. And coming to range, range equals to, for whatever the value of x, tan f(x) will be always 0. So this will be always tending towards the 0. So range will be always 0. Second one is f of x equals to x by 2 minus 3x. Domain equals to is 2 minus 3x should not be equals to 0. So x should not be equals to 2 by 3. So domain equals to, from the real number set, subtract 2 by 3. And coming to range, let y equals to f of x. So y equals to x by 2 minus 3x. That implies 2y minus 3xy equals to x, and 2y equals to x into 1 plus 3y. X equals to 2y by 1 plus 3y. X is defined only if 1 plus 3y is not equals to 0. So y should not be equals to minus 1 by 3. So range equals to r minus 1 by 3. So this is the range and this is the domain. Third question is f of x equals to mod x plus mod of 1 plus x. We need to find the domain and range for this. Domain can be anything here. It is defined for all the real numbers. And coming to range, if I put negative values, then the output is always positive. If I start with x equals to 0, then the output will be equals to f of x will be equals to 1. And if x equals to 1, f of x equals to, this is 3. So from 1 to infinity, I'll be getting the output. So range equals to 1 to infinity. Even if I put the negative values here, I'll be getting the positive numbers. So range is from 1 to infinity.